This topic is divided into 4 subtopics, and our group mate will individually explain about our understanding of LVDT. Assalamualaikum, my name is Nur Fatina Jiha binti Muhammad Harizal. In this presentation, I'm going to explain about the introduction of LVDT, short form of Linear Variable Differential Transformer. LVDT is a passive inductive type of transducer which require an external source. Therefore, LVDT is classified under principal use in transducer type. According to this figure, LVDT is a combination of coils and magnetic field to produce an analog output, which will transfer it to output voltage. Like commonly used transducer, LVDT is used to convert a linear displacement into an electrical signal. Most operated LVDT is under AC operation because it has strong resistance and also can operate under higher temperature range. On the other hand, DC operation is a simple operation and is limited by the properties materials. Okay, next let us continue. The operation of LVDT is easy to understand because it is very accurate with the mean given. Okay, let me explain it one by one. Since it is called linear, as I said just now, LVDT transducer is used to convert linear motion into an output voltage, which we can consider it as electrical signal. Then the differential is based on the difference of output voltage across secondary winding. Okay, based on the figure just now, we can see that the voltage has two difference. Based on the secondary winding I mentioned just now, LVDT has two types of winding, which is that primary winding and secondary winding, which is exactly same like transformer.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay. My name is Saiful Hasbullah bin Muhammad and I'm from BEEZ 1/2. Okay. For my part, I will be explain of the basic construction and operation principle. The transformer consists of a primary winding P and two secondary windings S1 and S2, one on a cylindrical former. Both the secondary windings and equal number of turns and we place them on either side of primary winding. The primary winding is connected to an AC source, which produces a switch in the air gap and voltage are induced in secondary winding. A movable soft iron core is placed inside the former and distance to be measured is connected to the iron core. The iron core is generally of high permeability, which helps in reducing harmonic and high sensitivity of LVDT. The LVDT is placed inside a sustain housing because it will be provide electrostatic and electromagnetic guidance. The both secondary windings are connected in such a way that the output difference between the voltage of two windings. This is the figure of LVDT and this is the 3D visual of LVDT, and this is input voltage, and this is primary and this secondary, which is S1 and S2, and these are output. Yeah. For the next slide is principle of operation linear voltage differential transformer LVDT. The primary is connected to an AC source current and voltage are produced in the secondary of the LVDT. The output in secondary S1 is E1 and the secondary S2 is 2. This is the formula of this LVDT. E out equal E1 minus E2, and this is the figure of the construction and circuit connection of LVDT. This is S1 and S2. This is a primary, and this is soft iron core in LVDT. While this displacement, this is circuit connection, and this is construction of LVDT. Yeah. For the next slide is different output voltage versus displacement curve. The graph shows the plot between the resulting voltage or voltage difference and displacement. The graph clearly shows that a linear function is obtained between the output voltage and core movement from the null position within a limited range of 4 mm. Okay. This is the graph different output voltage versus displacement curve for LVDT. Okay, for upward, different output will be positive, and while the downward is different output voltage will be negative. Uh, and for the left side, uh, it will be negative, while the right side is the displacement will be positive. Yeah. This is the important point about magnitude and sign of voltage induced in LVDT. Amount of change in voltage, either negative or positive, is potential of the amount and movement of core and indicates amount of linear motion. Hence, by noting the output voltage increasing the or decreasing, the direction of motion can be determined. The output voltage of an LVDT is linear function of core displacement. Okay. This part will show how the LVDT are working. Okay. For case 1, when the core is at null position for no displacement, and when the core is at null position, then the field leaking with both secondary winding is equal to the in which EMF equal in both the winding. So for non-displacement, the value of output out is 0 as E1 and E2 both are equal. It shows that no displacement took place. Next, for the case 2, when the core is moved to upward of null position for displacement to the upward of the reference point in this case, the field leaking with secondary winding S1 is more as compared to field leaking with S2. Due to this, E1 will be more as that of E2. Due to this output, voltage E out is positive. And then for the case 3, when the core is moved to downward, the null position for displacement to the downward of the reference point. In this case, magnitude of E2 will be more as that of E1. Due to this output, E out will be negative and show the output to downward of the reference point. Okay, that's all from me. And my partner or teammate will be continue for next time. Okay, thank you.
Hello sir, my name is Tarnabhai Rachanan. I am from BEZ1-2. The metric number is B08191035. The title of our team is Linear Voltage Differential Transformer. Today I am going to explain on application of linear voltage differential transformer. My first point is the physical quantity of force, tension, pressure, weight and more are measured by linear voltage differential transformer. These quantities are first converted into displacement by the use of primary transducer, and then it is used to convert the displacement to the corresponding electrical voltage signal. Other than that, VDTs are mostly used in industrial as well as servo mechanism. These are commonly used for position feedback in servo mechanism and for automated measurement in machine tools and many other industries and science application. Moreover, it is also used in industrial automation, aircraft, turbine, satellite and hydraulic and so on. Thank you.
Hi, Assalamualaikum. I'm Faiza Mahmoud from the 7. Want to present to you about the advantage and disadvantage of LVDT, linear variable differential transformer. Okay, first we got to look at the advantage of LVDT. First, it has the high measurements of range, which is start from 1.25 mm to 250 mm. It's a very high measurement. Second, it has the low power consumption, which is less than about 1 watt. LVDT cannot has a high power consumption. It only has a low power consumption, which is less than about 1 watt. Third, it is a featureless device that can offer the high resolution, which is greater than 10 mm. Okay. Fourth, LVDT has the high sensitivity of greater than 40 volts per millimeter that can be achieved, which is mean that LVDT has very high sensitivity. So we can conclude that LVDT is a very sensitive device. And lastly, for the advantage of LVDT, it has an excellent repeatability and it has a very low output impedance. It's a very excellent repeatability if you know, if you do some research. And it has a low output impedance. Okay, we move on to the disadvantage of LVDT. First, disadvantage of LVDT. Large displacement is needed for a small output. From this sentence, we know that small output, but we have to have the large displacement even for the small output. Second, it can affect due to the external magnetic field, and the entire of LVDT circuit need to be shielded and to achieve the desired accuracy. For achieve the desired accuracy, the entire of LVDT circuit need to be shielded. If the entire LVDT cannot be shielded, the accuracy cannot be achieved. And it can and LVDT can be affected to the external magnetic field. Third, the disadvantage of LVDT is vibrations. Vibration is due to displacement and can affect the performance of the LVDT device due to increase in temperature. From this sentence, vibration is bad for the LVDT because it can affect the performance of LVDT device. Due to increase the temperature. If the temperature increase because of the vibration, it can affect the performance of LVDT device. And lastly, for the disadvantage of LVDT is, in order to get the DC output, in order we want to get the DC output, the external demodulator, and for the last disadvantage of LVDT is, in order to get the DC output, an external demodulator is required, but it has a limited dynamic response for just the LVDT. Okay, that's all for my presentations today. Thank you for listening our group presentation.